Alrighty guys, welcome back to another episode of Making the Jarvis program. In today's episode, we're actually taking a step away from the main Jarvis. We're starting to code what I'm considering more like a Jarvis Google Home. The idea being is by the end of this series, we'll have something that relatively represents a Google Home. If I seem to be going a little fast in this video, this is actually the third time I've been recording this. The first time I pre-record a certain amount of episodes just because I am a college student and I don't have time. So of course, if you ever recommend something and I don't respond right away, or I don't cover that right away, that's why. In this example, we had actually coded an application. This is the Google Home. Let's actually not go from there. Let me change this. And I went too far. So we coded this application. When you run it, it gives you a clock face, accurate time and all that, the dates. When you click anywhere on screen, because mine's supposed to work on a touchscreen device. It gets the current weather for your location, which you can open up by clicking anywhere in that app, and it gets the weather here. I need to do some formatting, I can tell. You can actually click back and you can play music. You get the idea. I had coded all that, and none of it got recorded because it wasn't actually recording the second screen. So I was sitting there like, oh, as you can see here, it does this, and it wasn't showing up at all. So that was the first failure. Then the second time, the recording software that I use is supposed to record infinitely until I turned it off, and it stopped after like 5.5 minutes. It was like 5:38 or something when it stopped. And I had already started recoding everything on screen with y'all. So before I keep rambling on, let's just jump into it, and I'll just check my time, make sure it's still recording as we go. So for this program, we're going to be using Pygame. I know there's other versions such as, I think Turtle's one, I know Tkinter's one, PyAutoGUI. We'll be using Tkinter later on because I'll be coding a program that represents kind of like an app inside your computer that you can kind of do everything on. The idea is it's like your own operating system inside your computer. But anywho, for this application, we'll be using Pygame. I would say Python. Duh. We'll be using Pygame. So to get started, we're going to have to import Pygame. That's not how you spell import. Import Pygame. Some people import it as PY. I just prefer just to import it straight in. We're going to have to define some variables. So for starters, we have to initialize Pygame. So we'll just pull in Pygame. I cannot spell right now. .init. And then we need to define a width and a height. So we'll type out width, comma height. And that's equal to a number. So in my application, I want this to run on a Raspberry Pi's display. So I'll be coming back and of course editing all this code to work on a Raspberry Pi. But my display size is going to be 800 by 600. Set that to whatever you want. If you want it to be the full size of your screen, you can Google and find out what that size is, or you can probably look up in your owner's manual, whatever. The next thing is we need to define our screen variable. The screen variable is where everything will be displayed. Sometimes you might see that actually called just display. But that's equal to pygame.display.setMode, and you're going to pass in a tuple of width and height. Next, if you're having a standalone app, so like for example, I'm in VS Code right now coding. Up here at top, you can see there's, it says VS Code. That's the name of the app I'm running. You can define that. So the way you do that is you do Pygame .display .set caption, and then you pass in just a string of whatever you want it to be called. For now, I'm just gonna call it clock. Eventually, I'll be removing that in the entire upper area up here, but until then, it's fine. So next, we're going to need a couple of values. These will be used in probably the second onward videos because they're involved in the timeout circuits in here. That is the ticker, and that's equal to pygame dot, nope, that's not it. Pygame dot clock, no, time dot clock, capital C with clock. And then we need to set an FPS value, which is how many frames per second, obviously. And we're going to do 60. It's not super important. It's more just for the ticking ticker and the timeout circuits. It's a lot of T's. So next we're going to define a couple of colors. So for this we're going to define colors. We're going to define black, this is an RGB value. So it's going to be 0, 0, 0. White, which is 255, 255, 255, and red. This is all we're going to be using right now for the first program. As we continue, we'll be adding more colors to this as we add them. And red is 25500. Alrighty, so next we can get down into the nitty-gritty of coding our first screen. This first screen is going to be the clock screen. That's kind of like the generic. You can code that however you want. Eventually I want to come back and maybe make a few different displays. We can, go and change to whatever. And I would like to point out, in this program, every display that you see, so for example, in the original you have the clock, then you had the home page, then you had the weather page, then you had the one with music. Each of those will be its own definition. The reason is because inside the first off, so from the clock to the home page, when I click the clock, it just has to call the home page method. Once you're inside the method, I can run whatever. And the main thing in there is the ticker, which will time it out. And that makes it so that you don't have to worry about it giving us problems across different apps. If you defined one big file with if-else statements, you could have problems with the timeout, not resetting. But that's enough rambling. So we're going to define a definition called clock. And we're going to be passing, I just got out of class and I have to code in Java for class. So sorry if you see some mistakes like that. We're not going to be passing any values in here as of right now. I think later on we might, for some timers or like alarm clocks, stuff like that. And then we just need to call the clock. That'll make it so that when we click play and you run your Python program, it'll call the clock. For us, if you actually click play right now, you'll see a black little box pop up and go away. That just means that Pygame is running. So for this, we're going to define a running value. Running equals true. Alright, so with that running value, we're just going to have a while loop. So while running, we're going to say, we're going to go ahead and just code in the ability to end the file or end the program. Because if I run it right now, we'll just say pass. You'll notice you can't exit out. It's constantly loading. So I'll have to actually manually kill that from down here. To do that, what we're going to say is for event in Pygame dot event dot get. We're going to say if event dot type equals Pygame dot quit, and quit is all capitals and it does not have the parentheses behind it. We're just going to say running equals false. The reason, in case you're wondering, if I get louder, it's because my notes for like what I'm doing is on my phone, and I'm currently using my phone as a microphone because it's the best microphone I have right now. So if I turn towards you and get really quiet, that's fine, or really loud. But if we run it now, it's going to give us the same black screen running infinitely, just like this, but we can actually click the X now and exit. So the next thing we're going to do is we're going to code some values to get the current time and the current date. We're using the date for some formatting on the page just for fun. You could leave that out if you wanted. So to get that, we're going to do current underscore time equals date time dot date time dot now. Now, we don't have the date time package installed, so we need to import date time. Once we have that imported, you're ready to continue. We need to find a second, minute. That's not what I said. Gotta love autocorrect. Second. Okay, whatever, we'll just continue from here. Seconds, minutes. We'll say minute. Hour. Day. Month. And week. Day. That's not what I said. Day. So, to get the second number, we're going to say current time dot second. Super simple. No parentheses. And you're just going to continue down. For a minute, current time dot minute. Hour, current time dot hour. Day, current time dot day dot day. Month, current time dot month. Now for weekday, it is a little bit different. It's current time dot today. And then the today needs little parentheses behind it. Dot ISO weekday. And that's kind of the same thing. So what does this do? We get the current time from the date time. This is returned, if I'm not mistaken, as hours, minutes, second, microsecond, day, month, year. So then that's what we're splitting apart: second, minute, day, hour, month. Now this right here, we're calling the same date time. We're getting today, which will give us a value. It's not important really what that value is. And it's passing out the ISO weekday. ISO weekday is going to give you a weekday value from, I believe it's 0 to 7. I'll check that when we get lower down. I guess I could just look ahead. No, it's 1 to 7. So 1 to 7. 1 being Monday, 7 being Sunday. And we're going to be using that in that exact way, just, setting it equal to whatever day of the week it is. So, next thing we need to do is just define some dictionaries. So we're going to have a weekday abbreviation dictionary. And that's going to be equal to, or inside there we're going to store a value for 1, and that's going to be Monday. And then 2, that's Tuesday. And you get the idea. And we're going to go all the way through. Third, 5, 6, sat, and 7, sun. Alright, so next thing we need to do is we need to do the same thing for months. So we'll do month underscore APBR equals, we go 1, Jan, 2, Feb. You get the idea. On and on and on and on and on and on and on. So you'll have to do that for all of them. I'm going to steal it from over here. Right here. And come on. Control B. So now you have the weekday abbreviated dictionary and a month abbreviated dictionary. So next thing we need to do is find out what the new value is. So currently month is being returned, a value 1 through 12. Weekdays being returned 1 through 7. We want that to be a name. So if it's saying that's the first month, it's going to say it's January. If it's saying it's the third day of the week, it's going to say it's Wednesday. To do that, we're just going to do weekday underscore ABB R. We'll go ahead and just name it the same thing. We're going to change those just to be plural because that'll make it simpler. That's equal to that weekday ABBR with an S, so it's plural. Dot get. We're going to pass in the weekday variable or weekday number from up here. So that's what you're going to have. Weekday ABBR equals weekdays dot ABBR dot get weekday. And next we're going to have one for month. And we're going to make that singular. That's equal to month ABBR dot get. We're going to pass in month. Alright, next we're going to fill the screen with black. So that's screen dot fill. And then inside the fill, we're just going to pass in that black value. So that's just in case. I know on certain devices when you use this, it'll fill the screen white. So filling it black just gives us that black background. So next thing we're going to start doing is drawing. So currently we've gotten all our values for the time, the date, and formatted the way we wanted. So we're going to get into drawing the screen. And to start, we're going to draw some circles. So we're going to call pygame dot draw dot circle. I misspelled pygame this whole time. Dot draw dot circle. Inside circle, we're going to pass in the screen variable, which is your display surface. Screen. Then we're going to pass in the color, which we're going to pass in white for this. Next, we need to pass in the center coordinate, which is going to be a tuple, and that position is width divided by 2, height divided by 2. Next, we need to pass in the radius. Now, for the radius on mine, you can hard code this on whatever. For me, I'm using the height divided by 2, which means it's going to be the same height. We're going to subtract 10, which makes it a little bit shorter. And then the thickness of the line, which we're going to do 10. So if we run that right now, what's the problem? Oh. Yeah, I need to turn that off. I really don't know where that is in settings. Okay, run. You'll see nothing. There is a reason we'll see nothing. Alright, so now to fix that nothing, you need to come down here. We're going to say pygame dot display dot update. Now if we run it, you get a circle. If you're not getting a circle, first off, make sure you're not getting error. Second off, just make sure this pygame update is inside the while loop. If not, then you'll have problems. So the next thing we're going to do is we're actually just going to copy the same code and paste it. Oh no, I opened up. Go away. And paste. So just like that. And we're just going to change some values. So the only thing we're really going to change is this radius. Well, I guess radius and the thickness. We're just going to change that radius to be 12, and we're not going to set a thickness value. That's going to give us a middle dot. That dot is going to help cover up the hands of the clock, like where they meet. You could always place this after them if you want. I might look at that later and see how that looks, because I just thought of that. Okay, so on to the next thing. We now need to find one of those new methods. So we're going to come up here right above the clock method, And we're going to call it print line. You can call it whatever as long as you stay constant. Let me scroll back to my notes on that. So print line's going to need a string, a size, a position, a color, and we're going to default that color to white. Whoops, too far. White. Alright, and the reason we're doing this is because it's going to format our text the way we want it and apply fonts. Speaking of fonts, we need to define a font. So font equals pygame dot font dot sys font, which stands for system font. Then you can pass in the text that we're going to be using Arial, and then a size, and just to make sure I'm using that as an int. And then next we're going to just pass in true, which is for bolding. You could pass that in up here if you wanted. And then next is italicized, which you could also pass in up top. Probably wouldn't be a bad idea. Let's go ahead and pass those. Bold equals true, and then italics equals false. So we can go ahead and pass in, instead of those, we'll do bold with a capital B. And italics. This is just in case later on, I haven't even done this on any of my previous ones, but I haven't needed to. So just for something you could do. Alright, on to the next thing. We need to do our output text. So we're going to say out text equals font.render. What are we rendering? We're rendering the text that we wanted to put in. Text. We're going to do that with true. I'm not sure what that's. I don't know what that word even means or what it does. I just know to pass true. And then the color we want it to be. Then we're going to need to find a text rectangle, which is equal to text.get rec. If I'm not mistaken, get _ rec. We're going to pass in center equals position. And screen.blit text rectangle. Alright, so it should be out text. This should be out. So the idea is you're passing in a text, size, position, color, all those values. It's defining a font with that same size, and if you want it bold or italics, then it's rendering the text in that font with the color you want. Then it's getting a rectangle around that. That's the same size as the text at the positions you passed in, and then it's blitting on the screen at that text inside that rectangle. Hope all that made sense. We'll be using this a lot later on. Anytime we display text on screen, we're going to be using that. Now, we're going to start using it. What are we going to do? I didn't mean that. So, what we're going to do is we're going to call that print line statement. We're going to pass in a string, and it's going to be weekday abbreviated. Just a singular one, not plural. We're going to pass in a size. We're going to say 40. And then we need the position. For the position, it is a tuple still. We're going to do width divided by 2 minus 140. This is something you can alter in your own program to get it where you want it. Then we're going to do height divided by 2. So it's going to be halfway down the screen, and then about about a third the way across or so. We're going to do another print line. We're going to pass in a string value for the month, abbreviated, size 40 as well, and then the position is going to be, let's see, width divided by 2 is plus 60, then height divided by 2, divided by 2. Next we have one more, print line, string, and that string's going to be day. Not the weekday, the actual day. And then for position, we're going to pass in, where is it? Width divided by 2 plus 140. And then height divided by 2. So we run this now, and notice I placed it before this update. The update should always be the last thing. You can see Tuesday, November 1st. Now, you can just leave it like that. What we're going to do is we're going to put a little box around them. To do that, we're going to call pygame dot draw dot rect. And then we're going to pass in the screen, which is where we want it displayed, the color, which we're going to pass white, and then we're going to pass in a square bracket, and we have to pass in a whole bunch of values. We shouldn't need that. We're going to do width divided by 2 minus 180, height divided by 2 minus 30, where is it? There it is, comma 80, comma 60, and then we need to pass in the width of the line, which we're passing 1. What does it give me an error for? Floats. We're going to int these just to get rid of that float. It's not, it would never give a float because these are whole numbers divided, I guess maybe. They're even numbers divided by 2, so it wouldn't. Alright, so now if we run that one, you can see there's a nice little square around it. You could change that to whatever you want. These positions inside here stand for the start. These first 2 are your starting positions, and then the last 2 are your it's your width and height of the box. So we want a box that's 80 pixels in width and 60 pixels in height. We're just gonna clone that 2 more times. And instead of it being minus 180, we're going to do plus 20. And then plus 100. Just like so. And now if you run that, hopefully they're all in the right position. Yes. So you can see the boxes are all there. Alrighty, on to the next part. The next part is going to be printing the numbers around the clock. There's a few ways to do it. For our sake, we're going to be using a for loop. We're going to say for number in range from 1 to 13. There is a reason we're choosing those numbers. The reason is it's going to start at 1 instead of like 0, for example. And it's going to stop at 12. Make any sense? We're making an analog clock. They only go through 1 through 12. So we're going to be using those numbers in a moment. First, we need to define another function. This will be our last function for this episode. We're going to call it polar to Cartesian. Make sure I spell Cartesian right. And we're going to be passing in an R value and theta. So the reason we need this is because, and I'm probably wrong about this, it's been a long time since I first learned to do this. Either we're passing in a value in degrees and we need it in radians, or passing it in radians and we need it in degrees. I don't remember which one. Someone could probably look at this and tell me. Either way, let's get into it. So we're going to do we'll start with x. X equals r times sine, and in a moment we'll define these values. And inside sine, we're going to do pi times theta divided by 180. Next, we're going to do y equals r times cosine, cos, of pi times theta divided by 180. And then we're going to return x plus the width divided by 2. And we're going to do a negative y minus height divided by 2. Alright, so let's get these pi, cosine, and sine. Do so. We're going to come up here to the top. Let me get rid of this. We're going to import the math functions. But instead of just importing all of them, we're going to say from math import pi, sine, and cosine. So now all those are going to work. Your next question might be, why is this y here on the output in a negative number? It's not. The reason we're defining it that way is because if I run it and just point out stuff, obviously. Anywho, it would assume the screen here is the same pie game display that you're seeing. The top corner up here is 0, 0. Very bottom down here is going to be, in my case, 800, 600. So if we just passed a positive number out, it's not quite correct. I can show you what will happen in just a second when we pass that out. Let me go ahead and I'll show you a proof of concept on why. So we're going to need to use that print line again. So we're going to do print line. We're going to pass in the string value for number. For the next thing, the size, we're going to do 40. Position is we'll do 80. Let's make it a little bit bigger. And then it's going to be polar to Cartesian. Height divided by 2 minus 80. And then number times 30. If I remember correctly, the reason we're multiplying by 30 is there's 180 degrees. I'm trying to do the math in my head to make sure I'm correct. It's not correct, but just know 30 degrees. So this is it when you run it with the negative. Everything looks fine. That's the way we want it to look. If we just go up here and I'm going to take out this negative and show the output. Notice nothing there. It's because the value up here is being passed back as an... I'm trying to think it through my head to explain it and not use the wrong words. It's being passed back, if I'm not mistaken, as a negative already. So that's going to be running off the top. No. I remember. It is being passed back as positive. So, like I said, remember make your screen, 400 pixels tall, 600 wide. This number is going to give you, let's say, 40. Well, if you just pass back 40, it's going to be right here. But we don't want it at really 40. We want it at this value, our y position minus the height divided in half, which means it's from the center point 40 pixels off of that. It's confusing, just know that it works. I guess that's the only way to really look at it. But Anywho, we're done with that function for a second. That was well, we're really not. We're going to be using that for pretty much the rest of this definition or this method. But we're done with the numbers here. The next thing we're going to do is we're going to do the little tick marks going around. They're usually like a really thick mark right behind the hour numbers, and then there's 4 small ones in between each, and those represent the minutes. So we're going to do for number in range, and it's 0, 360, and 6. So inside there, what we're going to do is we're going to do if number %5, which means if it's divisible by 5, with no remainder. I believe that's divisible by 5 with no remainder. We're going to call pygame.draw line. We're going to pass in the screen. We're going to pass in the color, which we're going to pass white. And then we need our positions. For the starting position, we're going to pass in, guess what, polar to Cartesian. And then it's going to be height divided by 2 minus 15. So it's a little bit shorter than the original loop. And then number. Now for the next one, it's still polar to Cartesian. We need to pass in now height divided by 2 minus 30. And is it the same value? Yes, number as well. And then we need a width. And for this one, we're going to do 2. So if we run it, as you can see, it prints around. You see, there's the 1 minute, 2 minute, 3 minute, 4 minute, nothing. 6 minutes, 7 minutes, 8, yada, 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 all around. So let's copy this. Control C. And we're going to say else and paste that back. Because everything's the same, except 2 things. We're going to change the hour one to be 35 instead of 30. We're going to change the width to be 6. I believe that's everything. Yes. Now run it. And now you can see we have the hour tick marks like right here. And they stick out a little bit farther, and they're a little bit thicker. A little bit more predominant. All right. Last 2 or 3 things. We need to draw... Oops, I don't need to do that. We need to draw the hands on the clock. To do that, we need to define an R value. R is equal to the height divided by 2. Where is my divided by? Divided by 2. And then we're going to subtract 60. Now for theta, this is the more complicated one of the 2. Theta is equal to, in this case, second times 360 divided by 60. All right. Next. And the reason for that is you have to go 360 degrees around the circle in 60 seconds. That's the way I remember it. And you need that for each second. So that's why you're multiplying the second in. The next thing we're going to do is do the pygame.draw again. Pygame.draw.line. We're going to pass in screen. Now for color, just to make it a little bit different, I'm going to pass in red for the second hand. Now, whoops, go away. For the starting position, we're going to pass in that center, so width divided by 2, height divided by 2. Now for the stopping position, we're going to pass in that polar to Cartesian. And for the values inside there, guess what? R and theta. One of these times I'll spell theta right on the first try. And then we're going to pass in a width of 4. So if you run it, You see we got our little second hand going around. So now, pretty much just copy this and paste it 2 more times. Because we need one for the minute and one for the hour. So for minute, you could just change this, say, guess what, minute. But, yeah, minute. There is a reason we're not going to do that. Just doing that is going to make it look jumpy. You know how when you looked at the second hand, it was like tick, 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 tick from number to number? To change that to be smooth, what you're going to do is you're going to add in, oops, I pressed up. You're going to add in the second value, but seconds divided by 60, because there's 60 seconds in a minute. Alright, and then next thing, we're going to change this color to be white, because I prefer the white color for this one. We're going to change the, the thickness for this one to be 10. And we're going to change the height to be 80, so it's going to be a little bit shorter than the first one. If you run those now, you're not going to be able to see the second red hand because they're behind one another. And if you wait just a second, you'll see that it's slightly shorter. You can actually watch this. It's slightly moving. Otherwise, it would just jump from minute to minute. Almost all the way around. So you can pretty much tell now that yes, it is longer. So I can see there's a problem because you saw it skip back. I bet you, let me go ahead and add some parentheses here. I bet you that number was being executed wrong. Yeah, definitely, because it is 521. Yeah, not whatever that value was. So, make sure you add your parentheses around it. But alright, on to the hour hand. So we'll just start with the height. We're going to make it 50 now, so even shorter. But instead of just doing that, we're also going to divide the height by just 4. And we're going to add 50 instead of subtracting it. Alright, and then down here, we're going to, for this number, we're going to open our parentheses again. We're going to do hour plus minute. And minute is divided by 60 because there's 60 minutes in this hour. And then we're going to add in the seconds. And seconds can be divided by 3,600 because there's that many seconds in an hour. And I spelled minute wrong. There we go. Now we're going to change the color to be white. That's fine, that's fine, that's fine. We're going to change the width to be 14. So it's even wider. The idea being if it was, make sure my times. Did I mess something up? Let me look. Yes, I subtracted here when it should have been added. Let's see if that changes anything. Nope. That makes it worse. Well, I divided the height by 4. So it's a little bit of play. Like I could have divided the height by 3 then, or 2, but I divided by 4. So that's fine. Why are you giving me the wrong number? The current time is 5. It's 5:32 or 5:23. So the minute hand is on time. The hour hand is not. Let me just double check my numbers. So down here, theta equals minute plus hour divided by 60 plus seconds divided by 3,600 times. Okay. Notice how this one's at 60? How many minutes or how many hours are on the clock? How about 12? Run again. Now it's at the right time. Yeah, little bit of give and go there, but we're pretty much done with this clock now. If all you were doing was coding the clock, there you go, you're done. Now, in my case, we're gonna be doing a little bit more. So we're going to scroll back up a little bit. And right here where we did that quit function, we're going to add a new one. We're going to say if event.type equals pygame dot, and it's all caps, mouse button down, mouse underscore x comma mouse underscore y equals pygame dot mouse dot get POS, and then we're going to print out that position, print mouse x comma mouse y. So now if we run this, and while I'm right here, I'm going to go ahead and move this inner circle just to see if that looks better down here at the end. So now if we run this, I think that looks a little bit better. If we click anywhere on the screen, you can see printed out right down here is our position. That'll be useful later for like if I wanted to be able to click on November. I could go right up here and click, go right down here and click, and now I have the coordinates around where to build that. So yeah, that's going to be it for this episode. In the next one, we'll be working on, if I run this program, I could just show you. That was not the right program. Try again. Okay, we're going to be coding the first screen, this one right here. This is, there's certain things about it that are customizable, like for example, between 8 at night and 8 in the morning, the background will be black and the foreground will be white. You'll have the ability to click right here on this box, like if I click here, it says I can click on Google Calendar. If I click here, it says timer. Click on either of those, they'll go to the pages. This just would reboot it. And then after 30 seconds, if I just leave this alone, it'll click back to the clock. If I just wait long enough, just to show that functioning. But yeah, this is going to be what we work on in the next episode. I'm hoping that y'all are going to like this series. It's kind of if you wanted to code something in Pygame, this would really help you to learn. Plus, we're going to be implementing a lot of features like Google Calendar, music, timing, weather, stuff like that. Alright, and as you can see, it X'd out. So I hope y'all are enjoying the series, and I will catch y'all on the next one.